The broadcast is now starting. All attendees are in listen-only mode.
Yes, and good day, and welcome to the webinar, Should Manure Be Part of Your Crop Production System? My name is Dan Davidson, and I work with the Illinois Soybean Association. And on behalf of the Illinois Soybean Association and the ILSO Advisor Soybean Management website, I want to thank you for participating in this webinar today. The presenters are Kevin Erb and Morgan Hayes. Kevin is an Illinois native from around Champaign County. He is a University of Wisconsin extension specialist and provides training and extension activities on manure and nutrient management. Morgan Hayes is originally from Pennsylvania, but works for the University of Illinois Department of Agriculture and Biological Engineering. Conducts research and extension activities on livestock facilities and nutrient management. And today we're here to talk about, again, should manure be part of your crop production system, nutrient management plans. Just a few logistics. This webinar will last 1 hour. If you're a CCA and you registered for this event, you would have submitted your CCA number, and after this event is over, and if you participated for the whole hour, that your name and number will be submitted to the CCA program for credit. If you listen to the recording of this event online, you can go into your CCA account on the web, and you can self-apply for credit for having listened to this event. But you do have to self-apply for the credit. A little bit on logistics. We'll kick off in a few moments, and with Kevin making the first presentation, followed by Morgan Hayes, and then coming back and Kevin will wrap up. Then we'll go to some questions, and we'll have a discussion, and for the time that remains, and we want to promptly be done by 11 a.m. this morning, or just on the hour. So that's the logistics for the day. You're welcome to submit questions on your little panel on the right side of your screen, and then we'll compile those, and then we'll discuss them at the end of the presentation. Again, on behalf of the Illinois Soybean Association and also Advisor Soybean Management website, thank you for participating today. And Kevin, I will just turn it over to you now.
Okay, sounds good, Dan. Thank you very much. As Dan said, my name is Kevin Erb. I'm a certified crop advisor, agronomist with the University of Wisconsin Extension, based in Green Bay, and co-director of the Conservation Professional Training Program, which is a multi-state effort to provide continuing education and opportunities in ag, water quality, conservation to not only CCAs across the upper Midwest, but ag engineers and others as well. Before we get started, I do want to thank my co-presenter today, Morgan Hayes with the University of Illinois. We're going to tag team things a little bit today. I'm going to be talking some of the generalities and some of the specifics, situations that we've run into here in Wisconsin and across the upper Midwest with manure being transferred between cash grain operations and livestock operations. Morgan's going to jump in and midway through start talking about some of the Illinois specific things that you need to be aware of as you work with both livestock producers and cash grain operations themselves. And then I'll bring it back for sort of a wrap-up to discuss some of the social implications, but also the income tax implications of trading manure between farms as well. So as Dan said, there is the question box that you have access to. If it's not showing, there's a little down caret or side caret that you can click on. Please feel free as we go through things today to type questions into that box, and we'll address those at the end of the day. So as we're going through things today, the couple of things I always like certified crop advisors, agronomists, and cash grain operations to be thinking about when it comes to manure management. And I think the primary thing that we've got to look at is, how is it going to help my bottom line? How is it going to make me more profitable as a cash grain operation, but also from an agronomic standpoint, what are the considerations? And we'll talk a little bit about some of the weed seed issues. We'll talk a little bit about some of the agronomic issues as well. But from the landowner's perspective, we really need to be thinking about the economics and how it's going to help the bottom line. The second thing we're going to be talking about the paperwork hassles, i.e. if we're moving manure, does that trigger some regulatory paperwork? What are the things that both cash grain operations and certified crop advisors, agronomists need to be aware of? And of course, the third thing that we need to be concerned with and be thinking about is neighbor relations. So when it comes to manure, the benefits, in my mind, primarily the number one that I'm always talking with cash grain operations about is the nutrients and the financial. Manure is an excellent source of our major macronutrients, our nitrogen, our phosphorus, and potassium, but also a very significant source of our micronutrients as well, particularly as the coal-fired power plants have switched to low-sulfur coal and are now switching over to natural gas. If we go back 15, 20, 30 years ago, we were getting 5, 10, in some areas 20, 30 pounds of elemental sulfur equivalent per acre per year in the rain with the acid rain. Now in a lot of the Midwest we're maybe getting a pound or two, and in a lot of cases what we're getting from the precipitation is less than what the crop is removing. And so particularly in some of our sulfur demanding crops, we see it showing up in alfalfa, more visible than corn. But manure can be an excellent economic source of some of these micronutrients, and particularly boron, sulfur, and zinc. A huge source, and the impact that we've seen from some of these micronutrients can last 5 to 7 years after that initial manure application. And the other thing that I always like to talk about is the soil building aspects, but particularly as we get some of the more intense precipitation events where we get a lot of runoff and then we turn dry later in summer, the ability of manure to help increase the ability of the soil to hold moisture is paramount as well. So a lot of times farmers will say, well, manure's manure, and I think it's important to realize that whatever the animal eats or whatever's mixed in with the waste stream, if it doesn't become milk on a dairy, doesn't become meat on a poultry operation, on a swine or beef operation, it's going to end up in that manure stream. So one of the things we're looking at obviously is the urine, the feces. If we're talking about beef animals, we're talking about the animal bedding being added in there. We're also talking about the waste feed and any feed storage runoff, particularly from some of the larger operations who are under an EPA mandate for zero discharge. For dairy operations, there may be some waste milk and the parlor washdown water as well. I think it's important to point out here that the human septage is not allowed to be mixed with manure. So even if there is a toilet in the barn, the gray water from the sink can go in manure storage. The septage itself in most states is not allowed to. And before I move on, just one other thing to point out about the animal bedding here. A lot of concern I've heard, well, is that going to tie up my nitrogen source in the cornfield itself? And what we've seen is that if the farm is using sawdust for bedding, we need to be more watchful of what's happening that subsequent growing season. If they're using straw, if they're using rice hulls, we don't see the problem nearly as much. But let's get back to the benefits of manure from an economic standpoint. Depending on the species, depending on how much precipitation water, etc., is getting into that manure, we figure that every 1,000 gallons of liquid dairy or liquid swine manure is going to have somewhere between $6 and $35 worth of nitrogen, phosphorus, and potassium per 1,000 gallons. So a swine manure application that might be 5,000 gallons to the acre, we could be looking at from $30 to almost $200 per acre in terms of nutrients that we're actually putting out there. So there can be a significant economic benefit to it. Of course, on the converse side, you've got to look at whether that field actually needs those nutrients or not. And particularly heavy livestock areas where there's been livestock in the past, you may have some fields that were old pasture near the barn where the phosphorus and potassium may not be needed. For farms with fields farther away or lower fertility, that's where the benefit is going to be the greatest. What we've seen is that if we do this properly, farms can replace all of the corn's fertilizer application with manure, and as I said, reduce those future phosphorus and potassium applications as well. Most of the time, if we're applying the dairy manure, the beef manure to the corn's nitrogen need, we're applying more phosphorus and potassium than the crop needs. That's going to build the soil for the future. With the phytase that's been added to the swine rations, the nitrogen to phosphorus ratios are still about where they need to be, but we are building soil test potassium in a lot of cases. I strongly encourage the farms to grab an actual manure analysis, and I don't want folks to go to the edge of the pit, dip in a 5-gallon bucket and say that's good. We really need something that's thoroughly mixed, that's agitated. What I usually recommend is the guys have a coffee can and safely take 4 or 5 samples, maybe every other load, mix those together, send a sample to the lab. The cost is going to be between $30 and $45 to get that done. If you add in the micronutrients, it may be a little bit more, but that's really the starting point to figure out how much manure is actually worth when you put an economic agreement between farms. And I always recommend that it's the certified crop advisor, the agronomist, that makes that agreement between operations and negotiates that rather than the farmers themselves, just because of that independence factor. The other thing that we need to say is that while a majority of manure's nitrogen, phosphorus, and potassium are available the first year, it does break down in the soil slowly over time, and you will see an increase in soil test P and K levels in the future based on that long-term availability. Different species are going to give us different manure. We're going to have different consistency. Obviously, swine manure smells stronger than dairy manure, so there's going to be some different neighbor considerations, primarily because of the ammonia content. And depending on whether I'm swine, whether I'm beef, whether I'm dairy, whether I'm under the barn pit or it's outside getting rainfall, all of that's going to play a factor in how many pounds of nutrients are in every ton, every 1,000 gallons, and it's going to vary our rate as well, which is one of the reasons why that manure analysis is a critical part of moving forward. So typically for swine manure, in terms of total what's in there, we're looking, and the swine and beef numbers are provided by Illinois Extension, 58 pounds of nitrogen per 1,000 gallons, 23 pounds P2O5, and 33 on the potassium side of things. Dairy, because we don't have as much ammonia, we're looking at about half of the nitrogen or so, depending on the situation. Beef manure, here we're dealing with a solid rather than a liquid in this example, but what you'll see is that your nitrogen number is always higher than your phosphorus number. So the thing I also want to touch base on, and I alluded to this earlier, is the fields that have seen manure really seem to do better in our drier summers when things turn hot during corn pollination. And part of the reason is that we're adding organic matter back to the soil, which obviously has definite benefits there. It's increasing the soil water holding capacity. The other thing we're seeing, particularly in some of our tighter soils with a little bit more clay content, is that increased organic matter is actually increasing our infiltration rate as well. And I think this is really critical because we get into the hot time of summer, the end of the pollination window, and a lot of times, if we just have that rain at the right time, we would have had another 20 bushel to the acre, another 30 bushel to the acre. Conversely, we get into situations where we get just hammered with rain in spring. We can't get that corn in. We're losing a day. Every day we're losing half a bushel to the acre because of delayed planting. Adding that organic matter can hold the moisture in the soil, but also let us get out on those fields quicker in the spring as well. So the way I look at it, if we're putting manure on, one of our goals is to increase the amount of water that the soil can hold in dry years and allow it to drain more quickly to our drain tile systems and deeper in the soil profile in wet years. And I like this quote from Ken Kames. He's a farmer from just north of the Illinois border in southern Wisconsin. In 2012, he's very quick to say his corn averaged 140 bushel the acre. His neighbors didn't even bother combining in some cases because of how bad it was. Part of it is due to his long-term rotation of adding organic matter through cover crops, through manure. Part of it is some of the other things that he's doing, but it's an example of doing little things. Building organic matter through cover crops, managing manure properly, can have a huge impact in our really drought-stressed years. And a number of the cash grain farmers that I've worked with, that my brother has worked with in northern Illinois have said, you know, we see that benefit 4 or 5 years later, not only in the nutrients in the soil, but the water holding capacity and infiltration capacity as well. Now, we've talked about the positives. Manure can save a lot of money, can build soil, organic matter, increase water holding capacity. There's some negatives out there that we need to be thinking about and be aware of as well. Weed seed is a big one. And primarily where we see weed seed being an issue is where we're bringing in outside protein sources such as cottonseed meal, or whole cottonseed, or we're bringing in feeds from outside of the area. That's a way that we seem to be introducing a number of different weeds. I know that's what ended up happening with us on our home farm in Champaign County. We had a beef operation there, and our pastures were usually the first places where some new weeds would pop up. Really what I tell folks is you need to be on top of the scouting. That crop consultant needs to know that you've taken manure in. They need to be watching for two things. One is new weeds that you've not seen before, but the other thing is that if you've got velvet leaf, you may be bringing in a different subtype that may be more or less susceptible to some herbicides. And so herbicide resistance, the dynamic can be changed. Really what we need to be doing is scouting the fields and watching very carefully. The other thing that we need to be thinking about is neighbor relations. Manure smells. If we're taking livestock manure for the first time, if we're taking it, we need to be proactive. If we can get that injected or incorporated right away, we're going to cut our odor by 90 to 95%, and that's huge. I think the other thing, particularly for those that are not typically dealing with manure, is always keep an eye out. If you see a sign in the yard that says baby shower here, you see balloons tied to the mailbox, you see a tent in somebody's yard, probably an indication that you don't want to be spreading manure right next door to that particular house for those particular days. And if you're going to be spreading, if you've got a good relation with those neighbors, I strongly suggest that you pop in, say, you know, I'm going to be doing this. I just want to make sure that you don't have something planned that might impact it. The other thing I always recommend is touching base with your landlords and telling them, you know, we're taking this organic source of nutrients, and just wanted to let you know and keep you in the loop. Being proactive is really big. We need to be thinking about compaction. Liquid manure is fairly heavy, and so we need to be avoiding application when the field is wet if we can. And I'm going to show you some photos here in a minute of some different equipment, but if we can be looking at dragline application, dramatically cuts down on compaction in the field. This is a photo of a compaction pit that we did. This one was actually done in Guelph, Ontario a few years ago for a demonstration. But in this case, what we did was we excavated an area, put in 3 inches of soil, 1 inch of sawdust, and layered it, and then drove different weight manure equipment, different weight farm equipment, different tire pressures across, just to get a feel for what would happen in the soil. And I use it just to show you that, particularly the image you're seeing on the right, you can see that those compaction actually deflects and bends the soil down well past a foot into the profile. So we need to be aware of compaction and being out there at the right time as much as possible. The types of equipment that you may be seeing out there for manure application, we've got a lot of traditional tractor pulled equipment. We see the manure application industry using straight trucks, and the dragline, which is the photo that you see down in the lower corner there. We see a lot of folks, particularly in the flatter areas where we're hauling manure long distances, using semis. Where we've got some steeper slopes, we tend to see the smaller trucks being used. So the straight trucks, which are more common in swine operations with lower application rates, you're going to see those particularly in the hillier areas, typically 3,000 to 5,000 gallon tanks, can be outfitted with flotation tires for compaction and tend to work very well. The negative, of course, with both tankers and trucks like this is we're moving in and out of the field, tracking mud onto the road, and we'll show a way to avoid that here in a few minutes. For those that are dealing with solid poultry manure, solid beef manure, we've got a number of operations now that have taken your traditional side slinger manure spreader and mounted it on a truck chassis like this and are making applications this way as well. Tractor pulled tankers, we've got dual, triple, quad axles out there. The largest that we typically see is about 9,500 gallons. I talked a little bit earlier about compaction. A 9,500 gallon tanker with a tractor big enough to properly steer and to stop that is going to be well over 120,000 pounds. So this is heavier equipment, which is why I don't want folks out there when the fields are wet. Typically, the larger equipment like this does have the large flotation tires, which dramatically reduces soil compaction issues. A lot of times you'll see an independent suspension, which helps on slopes as well. If we look at some areas, we see semis being used to haul manure to the field, transferred into a portable tank, and then draglined or transferred into those tankers in the field. The nice thing about the semi-transport to the field is that I'm not worried about tracking mud on the road. It's very efficient. From that perspective, it does add some expense, obviously, usually about 6 to 7 tenths of a cent per gallon for the semi to other vehicle transfer. We do have some folks that are doing land application directly from semi, which from a soil management perspective is actually my last choice. What I really like to see from an odor perspective, from a soil compaction perspective, is dragline application. In this case, we've got a 5-inch hose, so we're running a 6-inch from the farm to the field, and then a 5-inch in the field. We have folks now running 7, 8, and even 10-inch lines, and we can easily do 2,000 gallon a minute through these type of systems, so we can be fairly quick and fairly efficient. We can also do surface application with those drag lines as well. In this case, you see an operation with an airway basically being sprayed on right ahead and manure soaking in through the airway tines. What I want to do now is turn the presentation over to Morgan Hayes. And Morgan, in a minute here, is going to be talking about some of the impacts in Wisconsin, or in Illinois, excuse me. Looks like I've got a slide that I forgot about here. The last point that I want to say in terms of weight is that when we've got this heavier manure equipment, we want to avoid, if we can, running on the edge of the road. If we can keep the center of that tire 16 or more inches from the edge of the asphalt, from the edge of the concrete, and we're not talking oil and chip, we're talking asphalt and concrete here, we can cut our pavement damage by 95%. So what we're recommending is that if we're doing the transfer, hauling, driving down the center of the road if we can, we've got townships that close roads to make them one way for hauling, and when the pavement is hot, the oil and chip or the asphalt, hottest part of the day, that's when it's the weakest, that's when we're going to be doing the most damage. So with that, Morgan, I'm going to turn it over to you to give a little bit more background on yourself and go through your slides.
Thanks, Kevin. So I was lucky enough to get the Illinois-specific sort of regulatory overview of what a livestock producer sort of has to handle in order to apply manure. So if you're thinking about applying manure, how you might be involved in their record keeping or the record keeping you might want to be doing yourself. In Illinois, manure is sort of managed under two sort of regulations. One is from the Illinois Department of Agriculture, the Livestock Facilities Management Act, and then sort of a secondary, not less important, but sort of a newer regulation that's sort of popped up is the Illinois EPA's Concentrated Animal Feeding Operation. And both regulations have a goal to sort of reduce the negative environmental impacts by approaching this from the point of view of applying manure at agronomic rates. The goal is also to reduce anything entering a waterway, to improve neighbor relations. The LFMA also basically handles permitting to ensure livestock facilities are properly sited and constructed to further prevent any sort of environmental impacts from that site. From sort of a general perspective, what information is used to determine an agronomic application rate? This is not any different than what you would do on a cash grain operation. Next slide. This is not any different than what you might be doing on a cash grain operation. We're looking a little bit differently in the sense that I know Kevin hit on this earlier, but manure is a variable substance, so getting proper samples and understanding the nutrient content of the manure you're applying is really critical. That's probably the one major difference between a manure substance and a commercial fertilizer that you'd be buying. If you buy anhydrous, it has this much nitrogen. If you buy urea, it has this much nitrogen. With manure, getting those samples properly placed is really critical to knowing what you're putting into the field. Similar to anything else, you're looking for what the crop nutrient need is, so you know what's coming off of the field with your yield. There's also a little bit of nuance to manure in that manure is stored, and over time, some of it volatilizes. That ammonium form, the part that goes off as odor, is a lost form of nitrogen. So the storage and the species of animals you have, as well as how you're applying it to the land, can all influence how much is lost. And there are some organic nitrogen sources in manure that aren't readily available immediately, but over time become available. Kevin also mentioned cover crops a little bit earlier, so they often are called green manure for the same reason. They have nitrogen that becomes available more slowly. And so we do have to account for that if we're using manure as not being immediately available, but in the long term as a benefit maybe later in the crop season. Next slide. So we talk a lot about either a manure management plan or a nutrient management plan, and the purpose of having one of these is to provide strategic, farm-specific plans to maximize nutrient utilization and reduce environmental impacts. You say, think of the 4 R's. I think a lot of cash grain, you get from the Fertilizer Institute a lot of times these 4 R's, the right source, right time, right location, and right rate. Basically, a nutrient management plan is designed to put all that information together in a farm-specific plan based on the manure that you're applying. The next slide. The nutrient management plan has 3 key elements in my mind that really benefit a livestock producer and might benefit you if you keep in contact with whoever you're negotiating to use manure from, to see their plan so you can understand the kind of information they have available. The plan has the who, what, when, why. It has the fields. It has what crop is on the fields. It has the type of manure that's being applied. It gives a lot of information from the agronomic standpoint. It also should have some key performance information. So they should have year-to-year soil test results. They should also have year-to-year manure results. So you can see how that livestock operation has been performing in the past. So you can kind of anticipate how that manure might help you moving forward. Their nutrient management plan, the livestock producer's nutrient management plan, should also have a protection element in there. It should have emergency response plans in the case of a spill or an issue. And you should see how they plan to handle the transfer and movement of manure depending on your negotiation. Who's responsible for certain things should be clearly stated in there. I know Kevin's going to talk about some of the tax implications, but clearly stating who owns the manure in the process of moving it and who's responsible for it is going to be really important to know ahead of time, because there are some liabilities with manure, because there are some regulations on it. I think it's really important to clearly write your contract so you understand what your liability is and what the livestock producer's liability is, and so that you both agree on who is handling certain things in the application process. At the end of the day, that nutrient management plan, if it includes your fields, because you've agreed to take manure, you will have to provide some of that information back to that livestock producer for them to keep in their records, again, depending on how you've written your contracts. And at the end of the day, all of this together gives you a whole farm nutrient balance and proper agronomic application rates. Next slide. So there's a number of different types of nutrient management plans, sort of a hierarchy of plans, with the least records at the bottom and the most records at the top. I'm not going to go into a lot of detail about the NPDES plan. NPDES is National Pollution Discharge Elimination System. It's a set of plans put together by EPA. It was predominantly set up for industrial applications, for manufacturing, for people who regularly discharge and treat water, and even some wastewater systems. And livestock ag has sort of been pigeonholed into this based upon the size of the operation, but it's sort of like a square peg in a round hole. It doesn't completely fit, but there's a lot of records that go into having an NPDES plan. And with the new CAFO rule coming from EPA, a larger operation, unless they apply for an exemption, would have an NPDES plan. In the state of Illinois, there are only about 40 or 45 NPDES plans on agricultural operations. But if you're negotiating for manure from a livestock operation, it would be important to know if they have one. If they do have one, they do have some pretty aggressive record keeping, and they will probably be asking for specific information from you as a result of that. The CNMP plan is a comprehensive nutrient management plan. It's developed by USDA or NRCS, the Natural Resource Conservation Service. It also has quite a bit of record keeping, and 5 years of records need to be kept for that plan. So people that have a CNMP and utilize it will also need a fairly large amount of records coming back from you if they're applying manure to your fields. The LMFA is the Department of Ag's plan. I'm going to talk a bit more about this later, about what's required for that plan. It's probably a fairly nice sort of middle-of-the-road plan that gives enough information, probably from a protection standpoint. If there were issues, if there was a spill, this would show that people were doing the right things, but maybe not quite as intense a set of record keeping. And at the very bottom is a basic plan. This would be someone who just wants to cover their basis but doesn't have a regulatory requirement. That might be the sort of records they would keep. Next slide. The EPA CAFO rule, I just want to sort of give a key point here. The transportation of livestock waste shall be planned and conducted so as not to cause, threaten, or allow violations of the Clean Water Act. There's two statements here, and they basically both tell us that when we apply manure, because there's a lot of water in it, we need to be careful not to over-apply or apply when the ground is very wet, because it will cause that water to potentially enter a waterway inside the state, a state of water in the state. And discharging manure into a waterway is not acceptable. If you do discharge manure into a waterway and EPA determines that you've done it in a negligent way, they will force you into an NPDES permit, which most livestock producers are trying to avoid. So you'll have to work with the livestock producer. Their goal is to avoid having a discharge event happen. Next slide. So I said before, the criteria to require you to get an NPDES permit. Basically, if you discharge, you become a concentrated animal feeding operation, and therefore you are required to have an NPDES permit. If you are a very large farm, you are defined as a CAFO, and a large farm is basically something over 1,000 head of cattle, thereabouts, or over 2,500 head of pigs. If you're working with a larger farm in order to get your manure, they may be defined this way. There is one form of an exemption. There's an ag stormwater exemption that would eliminate larger farms from having an NPDES permit, and it's called an ag stormwater exemption. Next slide. But basically, the ag stormwater exemption requires a whole bunch of things: agronomic application rates, land area, storage of the manure, conservation practices, soil tests, manure tests, winter application plans, emergency response plans, annual review of your records. All of this stuff together, in my mind, is a nutrient management plan. They don't define it that way, but essentially they still have a fairly aggressive nutrient management plan that they're required to keep in order to get that ag stormwater exemption. Most livestock producers that are selling or negotiating with manure with you are probably in this category. And this is the type of record keeping they're probably required in the state of Illinois to keep. Next slide. The LMFA's nutrient management plans. If you're under 1,000 animal units, EPA's CAFO rule and LMFA's nutrient management plan don't have exactly the same number of animals, and they don't have exactly the same definition of animals for what constitutes large or not large. But that 1,000 animal units is about 1,000 beef cows, or about 2,500 head of pig. So most farms that are going to be trying to negotiate with manure are likely in that category of over 1,000 animal units. If you're negotiating with someone under 1,000 animal units, they're not required to have a nutrient management plan. I apologize, that didn't come out well. As a result, they might not be keeping the same amount of records, but as I said before, a lot of them still have some form of record keeping that they're doing for their own risk management and their own nutrient management benefits. For those over 1,000 animal units, they are required by the Department of Ag to have a nutrient management plan. And for over 5,000 animal units, this would particularly be some of the poultry sites in the state, a lot of the larger sow sites in the state. They are required, and IDOA has approved it. So it will have, next slide, information like soil test results, crop yields, manure analyses, nutrient budgets, manure application rates, and then some other things like mortality, disposal, and earth and storage. If you are negotiating for manure with a livestock producer, the things that they may be asking you for to keep in their records are soil test results or crop yields, so they can produce proper nutrient budgets according to their nutrient management plan, so they aren't accused of over-applying their manure. They also will probably try and keep record of how the application occurs, how much occurs. Next slide, I believe. From a manure application standpoint, there's a 3-year record-keeping requirement here. This is the type of information that comes into that manure application that they'll probably be recording when you apply that manure. The dates, the fields, how it was applied, if it was injected or surface applied, the rate it was applied at, and the number of acres applied to, so that they can really get the total amount that they applied to a field. Next slide. I think Kevin hit on this earlier. There's sort of 2 ways we apply manure. We apply it based on the nitrogen and based on the phosphorus rate. For most cash grain operations, they don't have a buildup of phosphorus in the soil. A lot of livestock producers on some of their fields closest to a storage, they tend to get a buildup of phosphorus over time because they tend to apply more often than they perhaps should have in the past before they understood some of these management techniques. So most likely in your case, they're going to apply manure to meet the nitrogen demand, which means you will have a little bit of excess phosphorus and potassium for year 2 or even potentially year 3. Just so you know, they will test the soil before they apply. If it is over 300 pounds of phosphorus in the soil, they will use a phosphorus limiting rate, in which case they'll only apply the phosphorus need for the crop. That shouldn't be an issue for most cash grain operations, however. Next slide. The other major thing that comes out of the LMFA is land application restrictions. You need to inject or incorporate within 24 hours if you're within a quarter mile of a residence. That could be your own house or someone else's house. Next slide. This sort of shows a lot of times in a nutrient management plan, these are the sort of maps that will show up in there. They'll mark out on these maps the areas that need to be incorporated or injected. Next slide. You also have setbacks to wells of 150 feet. Next slide. And setbacks to surface water of 200 feet. Next slide. This is sort of a map showing the surface waters, and you can see here they've mapped out the area 200 feet on either side of the surface water. So if you were having someone custom apply your manure, or the farmer themselves that has the livestock is going to apply it to your field, they would want to create maps like this for the field that they're going to apply to, so they have clearly denoted areas where they don't want to apply manure and areas where they have to incorporate it. So if they ask you for fields that you would want it applied to, these are the types of things that they're probably looking for on those field maps and trying to get straightened out. One more slide, I believe. Just a couple additional setbacks from an application standpoint that might influence how they apply on your fields. They do need to inject or incorporate if they're within a 10-year floodplain. There's no application within waterways. They won't apply. They shouldn't be applying in ditches, and they apply primarily in the fall and some in the spring. They also will occasionally need to apply on snow, covered or frozen ground. In theory, that shouldn't be the goal to apply there anyway if they're putting manure on for you. But if they are using one of your fields to apply in the wintertime, there are prohibited areas, those with greater land slopes, or they lack adequate erosion control. And I think it's back to you now, Kevin.
Yep. So as we get into the home stretch here, just some final considerations that I'd like to repeat before we do start answering the questions. And as Dan had said earlier, you can type your questions into the question box there, and he'll be summarizing those and reading those here in the final few minutes. But I think just a couple of things. Obviously, manure has environmental considerations, and really the key thing here is that our rates of application are based on the nutrient management plan, not on a waste disposal strategy. Number of farms I've been on, waste disposal is the method they've used. We've had 10,000, 20,000, 40,000, 50,000 gallons of manure applied to the acre. We build up very high levels of phosphorus and potassium. We run the risk of increasing groundwater contamination, and so we really need to be aware of that. The second thing is, and this is particularly true in long-term no-till situations, in high clay soils as well, and that is that where our solids content in manure is less than 2.5%, we have seen manure move directly down to drain tile and end up discharging to surface water and causing a problem. And so if I'm in that kind of a situation, I need to be monitoring my drain tile outfalls. We recommend in the very high clay soils that actually the ground be pre-worked a little bit, a few inches below the depth of injection, just to prevent that from happening. And for those of you that have not seen something like this before, this is a dye test. We've done these in Wisconsin. This is actually one photo that I've taken from another state. But what you can see is on the right-hand side where it says dyed crack face, that's where we've actually poured some of this dye into a crack in the soil. And what you'll see is that dye moved downward, and then once it hit that plow pan or that compacted layer, it began to move laterally to the right and to the left. And so down about a foot or so, you're going to see that. And then if you see those earthworm channels there, it got to that point and then moved downward into the earthworm channels itself. And what we find is that earthworms, because they're like a turkey or a chicken, they have almost a gizzard type of digestive system where they need some grit. They're going to find that grit right next to the drain tile, and you're going to find a higher concentration of earthworms usually right around drain tile than say 5 or 6 feet to the right or the left. And so we do have the risk when we're applying very liquid waste products, whether it's biosolids, liquid waste from a sewage treatment plant, or whether it's manure, if our solids content in that is less than 2.5%, the risk is high enough that we need to be watching and monitoring. Drain tile are very difficult to find. I know my dad and I walked a number of fields, many years, trying to find where outfalls were, where they are. A couple of things I'm going to point out that we're using here in Wisconsin to locate drain tile. What you'll see on the left there is actually yield monitor data overlaid with where the farmer knows the drain tile is. And what we suspect in that upper left-hand corner there is we have some additional tile the farmer's not aware of. And so we can use yield maps to find drain tile systems. The other thing you'll see on the right there is actually an overlay from the most recent Google Earth air photo. Google Earth has a time machine function. You zoom in on a field, you can sequence through up to 20 years of air photos, and sometimes you're able to pick up things like this if the air photo was taken at exactly the right time. We are concerned, obviously, about nutrients and pathogens when it comes to manure. From a nitrogen perspective, if we're putting too much on, the crop's not utilizing it, we've got the potential for it to end up in surface water in the drain tile during the off-season or down into the groundwater as well. That's one of the reasons we really want rates to be limited based on what the crop needs and the nutrient management plan. Phosphorus is a surface water concern. Every pound of phosphorus getting into surface water can generate 500 pounds of algae in that receiving water. And so obviously the more phosphorus we can keep on the field, the better for the crop, but also the better for the environment as well. And we are concerned about pathogens and bacteria in manure making its way into surface and groundwater, which is why we need to follow the setbacks more carefully, just than we would with commercial fertilizer, for that very reason. For those of you that are in far northwestern Wisconsin or Illinois, or down in southern Illinois where we've got some of the shallow bedrock, some of the karst features, we need to be thinking not only about what's underneath the field I'm applying to, but where the runoff water from this field goes. Half-mile down slope in the woods, does that end up going into a sinkhole, into a crack in the ground, and getting into the neighbor's well water? From a neighbor relations standpoint, communication is vital. I can't stress it enough. Communicate, communicate, communicate. We've all heard the stories of where farms got into disagreements and it escalated, escalated, escalated. What I've seen is counties where we have livestock expansions going on and it's a minor deal. I've got other counties next door up here where it's almost open warfare between the agricultural community and the environmental community. Taking little steps, talking to the neighbors why you're taking manure, calling it a natural fertilizer, not a waste product, all of those things go a long ways really towards preventing problems in the long run. A couple of other considerations: if you're taking manure, who's responsible for the incorporation? How soon is it going to happen? If the dairy producer, the pork producer is responsible, you've promised the neighbors, yeah, we'll get it worked in within a day, and it's still sitting there 3 days later, you don't look good. So that needs to be part of the contract. Also part of any agreement is that if a problem occurs, guy takes a corner too short, drops the back wheels of the tanker, the tractor, off the end of the culvert, tanker tips over, who's responsible for the cleanup cost of the manure itself? And if the field is too wet to be applied, is that your decision to tell the manure applicator or the livestock producer, no, you can't come in, or can they come in anyway? Those types of things need to be in the agreement, and I always, always strongly encourage a written agreement between producers. Finally, here a little bit on the tax considerations and how agreements are worded. Depending on how that agreement is worded, it can either be an income or expense. You are getting something of value, i.e. the nutrients in manure, and so it needs to be taken care of very carefully. I always tell people to work not only with their attorney, but also their tax accountant as well. There's really a couple of different types of exchanges we see out there. We see Dutch treat, where I've got two livestock farmers. They may have land that's closer to the other's farm, so instead of passing each other on the road with 40 tankers, they say you take 40 loads to my field, I take 40 to yours. Where we have beef or dairy operations near cash grain operations, we'll often sometimes see a manure for feed. I'll buy so many tons of corn silage, soybeans, so many bushels of corn from you, you take so much manure. That type of agreement may have tax benefits. It may have tax implications. We see folks paying the nutrient value, first year availability for the nitrogen and what the soil test calls for phosphorus and potassium in terms of a value. And we also see some horse trading for service as well. You apply it to my fields, or I get the manure, and I'll fall till your land, I'll chisel your fields, I'll help you haul corn into the elevator, whatever. Those are some other things that we see out there. And so it really pays to have everything in writing first so that you've got a clear understanding, and you need to consult that tax attorney and your tax professional and an attorney as well. With that, I'm going to go ahead and wrap up here. I have both Morgan's email and mine up here on the screen. And with that, Dave, we'll turn it over to you to see if we've got any questions that folks have typed in. And you can still type in questions if you have them.
Morgan, question for you. Talk a little bit about the mortality disposal in Illinois.
Sure. In Illinois, mortality disposal could be burial, composting, incineration if it's an EPA acceptable incinerator, or it can be rendering. People that have a processing that they can get pickup easily, a lot of people utilize that. From a composting perspective and a nutrient management perspective, if people are composting their mortalities, they should include them in their nutrient management plan. A lot of times they'll utilize them themselves. They're a fairly high carbon source, but they can also be land applied.
Okay, and one other question too. When you listed all these plans people have to make, what is the enforcement that's behind these plans? Is there any enforcement?
With the new EPA CAFO rule, I suspect we're going to see more farm visits. We run a program called Certified Livestock Manager Training here in Illinois. So livestock producers with over 300 animal units are required to come every 3 years. And we give them actually an example of what EPA would use as a checklist if they came out to your site. And one of the predominant things that they look at is your record keeping. So not keeping records, I think in the long run, could be a fairly high risk thing for a livestock producer to choose to do. So if you're making negotiations right now, I think that there is sort of a increase in the amount of inspection that might be occurring, and therefore an increased demand by livestock producers that when they negotiate contracts that they do get records back to make sure that they really are accounting properly for all their manure. That's the only reason I bring it up so strongly here, is because I think livestock producers are going to start asking more and more often for cash grain operators that are taking their manure, for those people to maybe give them back those types of records that I mentioned earlier.
Okay. Kevin, question here. How do you calculate the value of manure in dollars per 1,000 gallons?
So what you're going to do is you're going to start off with that manure analysis. So let's take the example of, and I won't bring it up here, but let's go with that example where we had 58 pounds of nitrogen in every 1,000 gallons of swine manure. And let's just say that the manure analysis comes back from the lab, looks at the ammonia content, and that manure analysis says 40 pounds of that manure nitrogen per 1,000 gallons is available the first year. And of course, every manure sample is going to be different based on the ammonia content, but let's just say I do that. So I take that 40 pounds of nitrogen per 1,000 gallons. Let's say that my crop field, my nutrient management plan soil test says that I need 200 pounds of nitrogen, 200 units of nitrogen out on that field. 5,000 gallons is going to supply that. It's going to supply that 200 units of nitrogen that I need. So if I were to look at it from the perspective of, say, manure or nitrogen from the co-op or the FS being worth 50 cents a unit, I'm going to say that that 5,000 gallon application of swine manure, 200 units of nitrogen, the nitrogen value on that is going to be worth $100. So that's my starting point a lot of times when I'm working with cash grain operations and livestock farms. I'm then going to look at the phosphorus and the potassium in a similar way. But a lot of times, if my soil fertility is already high, I'm not saving the farmer any money with manure because they weren't going to apply the phosphorus and potassium anyway. So we always use that nitrogen because that's what's needed every year as the starting point, and then a portion of that phosphorus and potassium nutrients to calculate out what a fair price may be.
Okay. Another question: is incorporation essential or mandatory or regulated?
So I'm going to throw that back to Morgan here in a minute, but I will say that from a neighbor relations perspective, it's strongly encouraged, but a lot of our nitrogen in manure is in the ammonia form. And if we let that sit out there on the surface for a few hours, a few days, and it depends on moisture, humidity, wind speed, etc., we can lose an awful lot of the economic value of that manure just by letting it sit out there for a few days. And so from a economic perspective, I want that injected or incorporated right away. Morgan?
I think you hit the nail on the head there. The predominant reason you inject and incorporate is for your neighbor relations and your dollars at the end of the day. I did note the couple locations where you need to incorporate near a residence, in a floodplain. Those are really critical areas. I will say if you have a dragline system and a liquid manure stream, the speed at which you can apply and the cost to apply it with an injection system is actually most likely the same or slightly cheaper. So I don't know why you wouldn't if you have the ability to, but there are some solids and things that you can inject that do cost more, but at the long run you do save a lot of nitrogen that way.
Yeah, really look at that.
Go ahead, Kevin.
As I say, look at the nutrient management plan. It may have specific requirements for incorporation or injection that vary from one farm to the next.
Morgan, you talked about that 200-foot setback along waterways. Is that regardless whether it's incorporated or not, that all manure should be 200 foot back from a waterway, a surface waterway?
It should be that far back unless the waterway is at a higher elevation. And if there's no chance of it making its way into the waterway, you are allowed to apply up closer to the waterway. But just as a general rule of thumb, unless your waterway is particularly high and there's no chance of it seeping past, a hillside to get in there.
Okay.
Yeah.
So incorporation doesn't make any difference here?
No, that 200 foot
Okay.
is a setback.
Okay. And before we talked about these record keeping, and a question came in then, what record should cash producers keep? We're talking about the people that are getting the manure and applying it, and you made the comment about these people buying manure, they should keep some records. What records should they be keeping?
So on my slide, I think I highlighted a couple things. I think you're going to want to keep your soil tests year to year to keep track of what's going on with your soil nutrient levels. and probably your yields as well, but you're keeping those records anyway, most likely, because you're trying to gauge how effective what practice you're using on the field is. You probably want to know what that manure test result was that the livestock producer has, or you need to collect your own, either way, just so you know what you're applying. If you own the manure, you should also keep your application records, because a lot of times in Illinois, the livestock producer is viewed as the responsible party. But if you really own that manure, I mean, I think there's a chance if an improper application or a very heavy rain event comes right after you've applied, an unanticipated one, they could look at you. EPA could look at you as well. So knowing that you applied in a proper manner, I think, is important.
We're exactly at 11 a.m. So we want to wrap this up. I'll try to stay right on the hour. First time, Kevin and Morgan, thank you very much for taking the time out of your busy schedules to present this webinar today on manure and crop production. Thank you very much. Again, for the people that are listening to this webinar on the recording, a recorded version online on the Illinois Advisor, that should be posted in 3 to 5 days. If you listen and if you want to gain that or capture, receive that 1 CEU in nutrient management, you just have to go into your CCA account online and make that application. On behalf of the Illinois Soybean Association and the Illinois Advisor Soybean Management website, again, I want to thank everyone for spending an hour this morning and listening to Kevin and Morgan talk about nutrient management and crop production. Again, thank you very much, and have a good day, and this webinar is now over.